Okay, in this section, we're going to continue graphing linear inequalities, and we're just going to have systems of the linear inequalities. So that means we're going to have two lines that we graph. The solution this time of the system will be where their shading overlaps. So I'll be shading both the inequalities, and what I will do on the screen is I'll use two different colored highlighters, and then where the two highlighter colors meet is where the actual system solution is. Again, remember that you will use a solid line if you have a less than or equal to or greater than or equal to, and you're using a dotted line if it's less than or greater than. The shading, you can test the point above or below, or you can shade as long as it's a y equation, so as long as it says y is greater than or y is less than or y is greater than or equal to or y is less than or equal to, you can look at that and decide whether you shade above or below the line. So you shade above the line for greater than and below the line for less than, or you can test the point. So here's one system of inequalities. I'm going to graph both of them, and I'll use a different color pen for each one of them. So this one has my slope being -1, that'd be over 1, and my b value is 2. So I'll plot b, my y-intercept, and then I'll rise -1, and I'll run 1. Rise 1. I'm not really rising, I'm falling 1. You can see that negative slope, and I'll do that a few times. I'm going to be using a solid line, and then I will be shading above the graph here for my solution. So I'm shading above the graph. Okay, and I'll go ahead and highlight this one. This is the first line. The second line I'll do in green. It has a slope of -1/2 and a b value of 4. I'm going to plot the 4. I'm going to go down 1 to the right 2, down 1 to the right 2, or I could go up 1 to the left 2. This is a dotted line because it just says less than. And again, because it's less than, I will be shading below the line. So remember, my actual solution is where the two shadings overlap. So in this case, it actually turns it to green. So I'm going to write that off to the side. The solution is the green section. That's where the two shadings overlap. On the next problem here, I would need to solve for y on the second problem, so I'll go ahead and do that because I like to have it in y equals mx plus b form. So I'll add 2x to both sides, and so I get 2x plus 0, which I don't have to write, divide by -4, so I get y is less than or equal to, I remembered to flip the sign this time, -1/2 x. You can put plus 0, but not necessary. So that means the slope of this line is -1/2, and your b value is 0. So I'll plot 0. I'll go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. I will use a solid line, and I'll be shading below that line. That is less than. All right. The second equation has a slope, or the first one I actually should say, has a slope of 1 and a b value of 3. So I'll plot my b value. I'll go up 1 over 1, up 1 over 1. I know I'm going to be using a dotted line this time. And this time again, I'm shading below the graph. So because I'm using that yellow highlighter again, it's going to be where the two lines turn green is my actual solution, or where the sections turn to green. So I didn't actually fill in all this part down here, but all that would also be a solution. So I'll fill that in. And I'll put green is solution to system.